One of the most important concepts in Matlab software is the concept of arrays and matrices, and that's what the overall working of the Matlab is, that it works with matrices and arrays. So there are two types of arrays. One is the one-dimensional arrays, and the second one is the two-dimensional arrays that we'll be talking a little bit later about. So first, one-dimensional arrays, basically an array is a variable that can take more than one value. So until now, the variables that we were declaring would take a single value. So A would take the value 10, let's say B would take the value 20. Now, suppose that if A takes more than one values, like A takes 1, 2, 3, 4, 5 up to 10, now A is not a variable anymore, it's an array. So it stores values which are more than one in order of the same data type. So they're all numbers and they are more than one. There are multiple ways for declaring an array. One of the way is writing it in square brackets. So suppose that I want to store 5 numbers to a variable or an array A. So I'd write it something like this. So I'd write two square brackets, then 1 with a space 2, 3, 4, 5. You can either provide a space or you can also put a comma in each of these digits in between. So same thing goes for this. If you terminate with a semicolon, the result won't be displayed. But if you does not terminate with the semicolon, the result would be displayed. So if I hit enter, now the variable A is now an array that contains 5 values. Another way to declare a single dimensional array is something like this. So you start the starting number, then a colon in between, and then the ending number, which is, let's say, 5 in this case. If I hit enter, now it is assigned the same values. So this is another way of declaring an array with a colon in between. Another similar expression of declaring an array is with a step size. So suppose that I want to declare an array that contains values from 1 to 20, but with a step size of 2. So it's not with a step size of 1, like in this case, that is 1, then 2, then 3, but with a step size of 2. So the result would be like 1, 3, 5, 7, and so on. So in order to do that, you just have to write it in this format. So 1, then colon, then another colon, and then the ending number, let's say 20. So it will start with 1, it will terminate at 20, and it will take a step size of 2. That's how you generate a step size inside an array. So if I hit enter, now I see the result in A. It will be something like this. So 1, then 3, 5, 7, 9, 11, 15, and so on. So this is another way of generating it, generating an array. Now, other important thing, I'm assuming that the concepts of matrices or scalars is known to you. If not, then let's discuss them quickly. So here is an array that is in row shape. You can also declare an array that is in column shape. So in order to declare a row, an array in the row shape, so that's what it is used for. That's how it is coded. If you want to declare the same array but in column format, then what you would do is something like this. So A is equal to, or let's give it another name, B is equal to 1. Instead of terminating or putting a comma in between them, here you would put semicolon. So semicolon means the next row. So 2, next row 3, next row 4, next row 5, next row 6. You don't need to put the spaces in between once you put semicolon. I just put it here because I wanted to make it clear. So now when I hit enter, Now the same array is declared, not the same, I put an extra number in here, but now it is in column format. So it is in horizontal format. So that's how you generate array in column format, and that's how you generate it in row shape. These are all single dimensional arrays or 1D arrays. There's another type of array that is called two-dimensional array or matrix in mathematical language. So I should put the CLC in lowercase. So next thing is the two-dimensional arrays. So two-dimensional arrays are declared somewhat in similar fashion. So let's declare an array, two-dimensional array. So you would again use the square brackets, but now since two-dimensional arrays contains values that are both in horizontal axis and also in vertical axis, or in rows and also in columns. That's what a matrix looks like, that it contains values both in rows and also in columns. So for the row, you would write something similar like 1, comma 2. You can put space or you can put comma, both are okay. 3, 4. Now this is one row. Now suppose that I want to go to the next row. So I need to, when I need to go to the next row, I should terminate this with a semicolon. So now if I write 5, comma 6, comma 7, comma 8. So now all of this would appear in the next row. Now again, if I terminate with the semicolon and go further, 9, semicolon 8, not semicolon, comma 8, comma whatever, 3, 2. So now this is the first row up to this place. This is the second row up to this place. This is the third row up to this place. And all of this is assigned to the variable or the matrix or the two-dimensional array C. So when I hit enter, what is it saying? Undefined function variable. I'm defining it here. Yeah. So C equals to this two-dimensional array, or it is also called a matrix. So as I said earlier, 1, 2, 3 comes, 4 comes in the first row, 5, 6, 7 comes in the second row, and so on. So that's how you declare a two-dimensional array. As I said earlier, that there are a lot of useful predefined Matlab functions that are used for different purposes. So here we'd be I'd discuss two such important functions that are commonly used with the arrays and matrices, and those are the function length and the function size. So let's see what they do. So first let's declare a single dimensional array from 1 to, let's say, 10, and declare a matrix, let's say 1, 2, 3, colon, semicolon, 4, 5, 6, semicolon, 7, 8, 9, then terminate. So A is a single dimensional array from 1 to 10. B is a matrix which looks something like this. So length is basically used for how long an array is. So both arrays, like in a single dimensional array, it will just return you how many values it contains, and for two-dimensional array it will return the longest dimension. So if it has more columns, then it will return the number of columns, but if it has more rows, it will return the number of rows, the function length. So let's check it. If I say length length of A, so it contains 10 values, it should better return me 10, which it has. So that's what length does. Now if I apply the same function length on the variable B, so it will return me the highest dimension or the largest dimension which could either be rows or columns. In this case, they are both equal, so it will return me just one of it, either the rows or the columns, which is 3. So if I write length length of b, it will return me 3, right? The second useful function that is used with the matrices and the arrays is the function size. So size return me both the rows and the column in a matrix or in an array. So if I write size of b, so it has returned me a 3, 3 result, which is stored in a variable answer. So it has 3 rows and 3 columns. If I write the size function on a, it has returned me 1, 10. What does it mean? It is 1 row and 10 columns. So if you see here, it is just 1 row, but it is 10 columns, 1, 2, 3, 4, 5, and so on. So that's what it means. Let's declare a matrix that is not square. I mean that has more rows than columns or more columns than rows. So let's declare it 1, 2, 3, colon, semicolon, 4, 5, 6. So if you see, it is having 2 rows and 3 columns. So if I write length on M, it returns me 3, which is the number of columns, because the number of columns is more than the number of rows in here. If I write size of M, it returns me 2 by 3. So the first thing is the rows. First number demonstrates the rows, which are 2, and the second one demonstrates the columns, which are 3. So that's what the length command or the function is used for, and that's what the size function is used for in Matlab. So with this, we come to the end of our lecture. I know a lot of the things were a little bit quick and throw a lot of the concepts randomly. But since it was a general overview of the software and we weren't discussing anything specific, but just a generic overview of how the environment looks like and how the stuff works here and all that. So that's why it might look a little bit shaggy or something like that. But I'd strongly encourage to try all the stuff for yourself. Try different variables, try different operations, try combining some of the commands and play with them and see a lot of how the MATLAB generates the results and that kind of stuff. And try with different numbers, with different variables and all that, and make yourself comfortable with the environment and all that. Hopefully in the upcoming lectures we'd be dwelling more into the specifics, and there I would be explaining uh, these concepts in a lot detail and bit by bit, and would be able to learn more from there. Thank you.